Hi, we're here with Simon Rizkallah. He's head of optical transport sales for Asia, and we're talking about optical transport. Hi, Simon.
Hi, Sterling. How are you?
Very good.
Very good.
So convergence is a big topic of the day, obviously very important to Cisco as well, but when people talk about convergence, they mean different things. What does convergence mean to Cisco?
So it's an interesting question. What we've had, obviously, during the conference is a lot of questions around convergence. What convergence means for Cisco is really looking at the different layers within a network. First, we look at the optical layer, DWDM, then we actually look at the OTN layer, and we look at the IP and PLS layer. And when we look at all of those three different layers, we're expecting an element of communication to happen between them. So we have developed a conduit that allows for information flow between those different layers. And as they communicate between each other, they're able to actually develop new efficiencies across the network. New efficiencies from an understanding of the different layers, what they're doing, their resiliency mechanisms, their latency, etc., and allows things to become a lot more efficient.
So what are the key trends driving this convergence?
Very interesting. So what we're seeing at the moment with service providers in particular is they're looking at reducing cost. Reducing cost and increasing profitability. That's always been a key driver for something like convergence. Also from a time to market, service providers, when provisioning services, can take weeks, months to be able to provision a service end to end between the multiple layers. So with convergence and the way we've developed convergence, it allows them to turn that into minutes rather than months and weeks. So the other thing that we also look at is there's an explosion of traffic across the internet. How do you accommodate for that explosion? You need to reduce your cost per bit. So there's a lot of things that occur between the different layers that allow you to realize those network gaps or network efficiencies so that you can actually utilize them. So they're the couple of things that are really driving the convergence within the industry today.
So can you tell me what are your views on OTN switching, and specifically what is Cisco doing that others aren't?
I believe that OTN switching is mandatory in the environment today, particularly as we go to new bandwidths. The existing SDH networks are not going to be able to support those bandwidths, those profiles. And so OTN allows us to be able to support those higher end bandwidths with ODU 0, 1, 2, 3, 4, and even ODU Flex for flexibility. What Cisco's doing very different in this space is really developed a converged platform called the NCS 4000. And the NCS 4000 allows us to leverage OTN technology for OTN switching. It also allows us to do IP MPLS and MPLS TP on a single chassis. And at the same time, it allows us to do VC switching. And so by combining all of these things together, you're able to transport your TDM traffic across OTN technology. You're also able to transport your IP traffic across the same chassis. And the nice thing about the NCS 4000 is it has a single unified switching fabric that's cell-based. And what that means is it means that I can have both TDM traffic and packet-based traffic aggregated and sent on a single wavelength, rather than having them sent on two separate wavelengths.
SDN is another hot topic in the industry these days, and especially seeing a lot of momentum around transport SDN, application of SDN to the transport network. What are your customers telling you about transport SDN, and specifically, what do they want from you in transport SDN?
Very interesting. So transport SDN, well, I'd like to label it more about SDN, because SDN looks at a network end-to-end rather than just the transport side. If we just did transport for SDN and we separated it from transport from IP, then you'd actually have two SDN controllers that, again, you have the same problem of having to allow them to communicate with each other. So we look at SDN as being an end-to-end automation of the network, allowing you to simplify the network, allowing you to take out those delays, those long time delays, and through automation, you're able to introduce new types of services for revenue generation. So from our perspective, I think a lot of our customers are telling us SDN is something that's going to happen in the longer term rather than the shorter term. And of course, there's a lot of legacy platforms that actually need to be supported. And SDN doesn't necessarily manage those legacy platforms. So there is that key concern there moving forward. The other big concern that our customers have around SDN is around proprietary versus non-proprietary. And I think that is definitely one of the hottest topics out there today. We have many different interfaces, whether it's OpenFlow, whether it's NetConf, Yang, whichever we want to program in. And so many vendors are using many different methods. So again, I think there needs to be a standardization of some sort so that we can all work to the same cause. But at the same time, I think we need to take into consideration those legacy platforms that may not necessarily be supported from day one, and will take time for them to be migrated to the newer platforms.